Hello, in this video I'm going to be going over some of the basics of probability. Probability is the good outcomes, the outcomes that work for your specified condition, over the amount of total outcomes that could occur in the case that you're given. So, written shortly, it would be good outcomes over total outcomes. It's the outcomes that work for the case over the total amount of options that can occur in that case. So we're going to move on to this example over here. We need to find the probability of flipping tails on a standard coin. So I've got this, it's a magnet. We're going to pretend it's a coin with a gray and a black side. So if I flip it, I want to find out the probability that it'll land on tails. So we're going to be solving that by using this method. So how many good outcomes are there for this? Well, there's only one way for it to land on tails, just if it lands on this side. So that would be 1. And then how many total outcomes are there when you flip a coin? Well, it could land on tails or heads. So you have 2 outcomes. And you could read that as 1/2. So the probability of flipping tails on a standard coin is 1/2, as you might have already known. Now we're going to move on to a much more difficult problem. But you're going to see that it's really just going to be using that way of solving it, that method. We're going to find the probability that an arrangement of the word algebra contains 2 A's next to each other. So I see the word probability, I go over here and I think good outcomes over total outcomes. So now let's start with the denominator, the total amount of outcomes. That would be the total, in this case, the total arrangements of the word algebra. How many different ways can I arrange the word algebra? I could say LA, BGERA, and a lot of other cases. So to figure out how to solve that, I'm going to start with a more basic case. Let's say we have the word ABCTA. It's a real word. You can go in the dictionary and look it up. So how many different permutations, how many different arrangements are there of this? So there are 4 letters in it, represented by those 4 lines. So for the first letter, we can have 4 different letters go into it. The A could be the first letter, the B could be the first letter, the C could be the first letter, or the D could be the first letter. So there are 4 options that you could have for there. We'll pretend that we chose the D. Now for the second letter, there are only 3 letters left that could be in there. So there are 3 options for that second letter. We're going to pretend it's the B, cross out the B. Now for this third letter, there are only 2 options left. And then for the last letter, there's just 1 option left. And since we're doing these events next to each other, independent on each other, we're going to multiply them. So the answer is going to be 4 factorial, or 4 times 3 times 2 times 1. Now we need to check another case. Let's say I have the word ABCA. Okay, ABCA. This also another word. It's right in front of that word in the dictionary. You could look it up. It's a type of dog. So how are we going to solve this? How many different permutations are there of this word? The difference is that now it has 2 A's instead of all the letters being different. So we're going to start the same way. We can say you could either have this A in it, the B, the C, or that A in it. And then we'll pretend that we crossed off the B. Then we could have either one of those 3 in it. We'll pretend we cross off the A, then either that A or C. And then we just are left with the C. So this you could think would be the answer, but we run into a problem. If I have the word, or the arrangement over here, B1, the first A, C, and then that second A, another option I could have is this over here, where I flip the positions of the A's. So this is the same word. They're both just the word baka, or the arrangement baka, but in counting with this method, I counted them twice. And you can see that every single arrangement I have, I counted twice by flipping over the A's. So the answer is going to be 4 factorial over 2 factorial. And I write 2 factorial, not 2, because if there were 3 A's, there'd be 6 different ways I could arrange all the letters, which would be 3 factorial. So now with this newfound information, we can solve for the denominator. Okay, so the total number of outcomes, the total arrangements of the word algebra. So let me write it up here. So algebra has 1, 2, 3, 4, 5, 6, 7 letters. Whoops. Has 7 letters. And so it would be 7 factorial, but then it has 2 A's. And so for each position of the A, we're counting them twice when we only need to count them once. So I'm going to divide by 2 factorial. So the denominator is going to be 7 factorial over 2 factorial. Or you could just write 2, same thing. And now going over to the numerator, the amount of good outcomes. How many good outcomes are there? Well, the good outcomes would be when the arrangement of the word algebra contains 2 A's next to each other. How many ways can the permutation of algebra have 2 A's next to each other? So to solve this problem, I'm going to be using a sneaky little trick. I'm going to pretend that the 2 A's are 1 letter. I forgot an E. And so now, instead of having the word algebra, we have 2 A's together that act as 1 letter. That way, they're always going to be together in any way that I arrange this, because we have 1, 2, 3, 4, 5, 6 letters. And so we have 6 factorial ways to arrange this. So for example, we could have it be L-E-A-A-G-B-R. That would be one arrangement of it. And we can see those 2 A's act as 1 letter altogether. So in the numerator, we're going to have 6 factorial. And now we could actually solve this. That would be 6 times 4 times 3 times 2 times 1 over 7 times 6 factorial. So it would be 1 over 7 divided by 2, which equals 2/7. And that right there is the answer. Thank you very much for watching, and goodbye.